go. Tell me what I need to do first. It's what? Yes. Set up the matrix. Okay, how many matrices am I setting up?
2 by 3.
2 by 3?
Or 3 by 2 by 2.
2 by 2?
2 by 2, right? You have to
We need 2 by 2 because we gotta have our x and our y. If we did it in the calculator, it would be a 2 by 3. We could do that rough thing, right? So if this was on the calculator portion of your test, you absolutely could solve it like we do with the 3 dimensions. But what does this say?
No calculator.
Yeah, that's like a thing. Okay? Alright, so I got my x values and my y values, and I have my equation 1 and my equation 2, right? Yeah? And then we're going to have a separate matrix.
Separate?
Yeah, separate matrix with our constants.
I thought it was together.
I'm going to show you what's actually happening, and we're going to talk through it. And then we're going to talk about what you actually have to show and what you actually don't have to show, okay? So, what are the coefficients of my x values? -5 and 1, right? If you need to write the 1 in there, please do so. How about the coefficients of my y values? Gorgeous. And then what values go here? -16 and 12. Right? Because if I went through and did matrix multiplication here, I get -5x plus -2y equals -16, right? So I just took this and I broke it apart into matrices, right? It turns it just into an equation. It's a goofy equation because it's matrices, but it's just an equation, right? And if we have an equation and we have to move something from one side of the equation to the other, what do I have to do? If I have to take something, so if I had like 3x equals 15, what would you do to solve that? Divide. Why would you do division? Because it's the opposite of multiplication, exactly. If I had x minus 3 equals 15, what would you do? You'd add. Why would you add? It's the opposite of subtraction. So we're going to rephrase that word opposite, okay? Because that's not technically the right math term. When you say opposite in math, you're just talking about positives and negatives. But when you're talking about the thing that undoes the other thing, the inverse. We're always doing the inverse to move things to the other side of the equation. Does that make sense? Okay? And that's what we're going to do here. Do you know how to find the inverse of a matrix?
Yes.
Let me rephrase that. Have we talked about how to find the inverse of a matrix?
Yes.
And we can review it, right? So we have to find the inverse of this guy to bring it over to here so we can multiply these guys and figure out what x and y equal. Does that make sense? Okay. So, in the video, they normally label this guy as A, right? And this guy is B. The key for you, do I want to, and we'll talk about it when we get there if we need to. We got to figure out whether we want to do this or whether we want to do this. Does anybody remember which one you want to do? Why the first one? Anything? Any sort of like inkling as to maybe why? Just alphabetical? That's a really good guess. I could have labeled those whatever I wanted though. It's going to be this guy. We're going to circle back and we'll see why it is, okay? Can we play the trust game on that for a second? Okay. So, first thing we got to do is you got to find the inverse of this guy. So if you like steps, actually the first step is to set up your matrices. Who are we kidding? Set up matrices. And your second step is to find A inverse. Yeah? Alright, let's do it. I want more space. Do you remember how to find A inverse? I'll give you a little context. Oh, now that's gone. Oh, that's creepy. Poltergeist, don't worry about it. I need to find what the inverse of this guy is. That was the first day we did the 3 rotation when you were with me. I showed you that shortcut for how to find inverses. The ABCD thing where we flip it all around. Yes, that's exactly what it is. So when I move my matrices all around, what is it going to turn into? -4, what's going to go here? +2, good. -1 and -5, very good. Remember doing that? We flip these two and we change these two signs. Right? You got to do one other thing though. What else do you have to do?
You have to do 4 times -1 times 5, you take the bottom.
No, but there's something else involved with the matrix here. I need something in front of this. Remember?
You have to like cross multiply.
What's that called? That thing that's like cross multiply. So close.
Oh, the
Determinant. Determinant. You're close. We gotta find the determinant of this guy, right? So when you're finding the inverse, you have to find the determinant of A, and you've got to swap your matrix. Okay? Whatever you need to write here so that makes sense. If you want to put the little A, B, C, D thing down so you've got your steps, please do so. And how it switches into D, -B, -DA. Okay? So far so good? Okay. So, if I'm finding my determinant of this, what am I going to do? I'm going to do that in a different color. What do I do to find the determinant? -5 times -4 is +20, good. 1 times -2 is, and then what do I do? Subtract in what order? Bottom minus top, which is 22, right? 20 minus a -2, right, is a 22. That is your determinant of A. How do I put that here? 1 over 22. Very good. So far, so good? All right. What do I do now to deal with this guy? We're going to go back to fun colors because it makes us all happy. Yeah, we're going to distribute this guy basically, which is multiplying to all of these. And I'm just going to leave them all with the denominator 22. I'm not even going to bother reducing stuff because this is actually going to make my life a little easier to be lazy here. Okay? Cool? Okay. I need to find this guy right here is my A inverse. And I need to find, what's my dimensions here?
2 by 2.
Good. This guy's a 2 by 2. And what's our dimension of the B that we need to multiply with it?
2 by 1.
So what's the only way we can multiply these two together? What order?
A, B.
Exactly. Why won't multiplying B times A work?
There's a 1.
Because there's a 1 and those two middle numbers wouldn't match up, right? Do you understand what I'm saying? Do you need me to write it down? Tell me if you need me to write stuff down. Let's check it out. This guy, A here is a 2 by 2, B is a 2 by 1. So those middle numbers match up for multiplication, right? If I did it in this order, I'd have a 2 by 1 and a 2 by 2. That would not work. Does that make sense? Yeah? So it's your only option. Okay? Alright. So now I have to take that guy and multiply it by my B. Yeah? So what is going to be the dimensions of my answer? A 2 by 1.
Can you draw the little arrow? Like from the, like what it is? No, down the bottom, like from the 2 by 2 to the 2.
Yes. You want this and this guy? Got you. All the visual cues. Good. Thank you for asking for it. Okay, so let's go through some matrix multiplication. What am I doing?
-4 by -16.
Okay. And that's going to still be over 22, right? Because this is technically over 1, right? You only have to really deal with the numerators. We're just going to let the denominators hang out. We're just going to let them chill. So 4 times 16. First of all, is it going to be positive or negative? It's going to be positive, right? Negative times a negative is a positive. Math, the only place where 2 wrongs make a right. Okay? Quick way to multiply by 4 in your head is to double something and then double it again. So what's 16 doubled? 32, and 32 doubled is 64. So that's that guy times that guy. So then what's this guy times this guy going to give me? Right? Remember when we do multiplication, we do rows with columns, right? So we do first guy with first guy, second guy with second guy. Right? I don't want to put too many lines there. That'll throw you off, though. 24. Anything else you want to add to that? All good there? Right? Okay. So then how about my denominator here? I still got 22s. 16, good, and it'll end up being positive because we have a negative and a negative. And then how about these guys? Negative 60, right? Multiplying by 5, think about the clock. When you're at noon, right, that's 60 minutes, right? Do you see why we didn't reduce our fractions now? What happens when you add fractions? What do you need? Common denominator. We already have one, so don't bother reducing here. You'd have to, like, bring it back. It would just be annoying. Does that make sense? Okay? So all you have to do is add the two tops together and simplify it, and you are done. So what is 64 plus 24? And what is 16 plus 60? So, what is your answer?
It's 4 and 22 is like 3.5. Oh, that one we should keep as fraction.
I feel like that should end up being a nice number. Do we screw up a negative somewhere?
Why?
Yeah, the 60 should be negative.
Ha.
You should get nice things. I'm not that mean. There's so much process here. I am not that mean. It ends up being magical. That should click you in. So the fact that that didn't divide nicely. So let's talk about that real quick. I'm glad that happened and we could experience it together. Because this was a negative 5 times a positive 12, right? So it needed to be a negative 60. So what's 16 minus 60? You got $16 to spend, but you want to spend $60. How much money are you in the hole? 44. Does that make more sense? That divides real nicely. So what's my answer here? Negative 2. I'm not trying to ruin your lives and give you crazy things. If the process is this intense, you should end up with a nice answer for a problem like this. Besides, not that mean. So what does this mean?
Like in the context of a real world problem?
Yeah. Do you remember solving systems like linear equations? This is x equals 4, y equals negative 2, right? Because this guy equals this guy. What's the other way you could write this? 4 comma negative 2? In parentheses, because it's a what?
A point.
It's a point. It's a point on a graph. Okay? Do you remember solving systems of equations? It means that there's like a line over here, and there's a line over here, and you're finding where they meet each other. That's what you're doing when you solve systems. You already learned them with elimination and substitution. This specifically said in the directions to use matrices to solve it. It is.
But wouldn't it be easier?
It's not the point. The point is the skill. You feeling any better about that? I was doing all wrong.
That's okay.
Because I didn't know you were supposed to, like, multiply the other columns in the bottom. So let's go back up to our steps real quick and just finish it, right? Because the last thing we did here is we multiplied A inverse times B. So there's 3 steps. You're going to set up your matrices. You're going to solve for A inverse by finding the determinant and swapping the matrix around. And then you're going to multiply A inverse by B. Yeah? Don't want me to pop up another example? Okay, I'm going to stop the recording though. Okay?